So a question that often comes up when you're talking about data science is what about big data? So big data is obviously different to different people. So big data for somebody without a computer might be 1,000 numbers, but big data for somebody with access to Amazon EC2 might be enormous, much, much, much larger. So how much data is there? So this is an infographic that says that in 2001 there will be 1.8 zettabytes that were created, which is a gigantic amount of data. But realistically, only a tiny fraction of that data can be used to answer any specific question that you might have in your mind. So the question that keeps coming up is, what about big data? So you often see things like big data and cloud management, and cloud and big data tend to go together, and that's because for some data sets they're so big that you can't analyze them on your local laptop computer. So it really depends on your perspective. So this is one of the very first hard drives, so created by IBM, and so it was able to contain much less data than you could even store right now on your computer or even on your cell phone. And so what this suggests is that over time, as technology increases, big data will change. And so one way to solve the big data problem is to just sort of wait until the hardware catches up with the size of the data. But most questions that you're trying to answer don't necessarily have that big data component that necessitates the need of huge numbers of computers, although sometimes it does. So why is big data such a big deal now? Well, this is one example of that. So there was an experiment run by Stanley Milgram where he took 296 individuals, and what he tried to do was basically send them a letter and ask them to send a letter from someone they knew, and so forth until they went to a specific address. And so 64 of these such chains came back, so 64 out of 296. And from that, they found out that there was about 5.2 people in between the person that originally got the letter and the person that finally received the letter. And this is where the sort of 6 degrees of separation sort of came about. And so what ended up happening is that people nowadays can collect much more data than they could before, and much more cheaply. So these investigators took an instant messaging network and they looked at 30 billion conversations between 240 million people. And then they performed a similar sort of experiment to try to identify how far apart people were. And they looked at to analyze the same question that was looked at with just 64 email chains before. And they found that the average path length was actually 6.6. So they sort of upgraded the 6 degrees of separation to 7 degrees of separation. So what's the take-home message here? The take-home message is that it's now possible to collect much more data, much more cheaply than it was before, and to analyze it. But the question is how much of that data is useful for answering the question that you're involved in. This is sort of a tongue-in-cheek post that says, don't use Hadoop, your data isn't that big. So Hadoop is another one of these buzzwords you frequently hear around big data, and it is an incredibly powerful and useful technique if your data is very, very large. But if you have enough memory on your computer, or you have a powerful enough computer, you can analyze a large number of data sets that are important and relevant to you without having to get into the more complicated techniques that are induced by scaling up to massive size data sets like those analyzed by Google and Facebook. Big or small data that you need, regardless of the size of the data, you need the right data. So the data may not contain the answer. The combination of some data and an aching desire for an answer does not ensure that a reasonable answer can be extracted from a given body of data. This was a quote by John Tukey, one of the first data scientists, and I would add to it, no matter how big the data are. So even if you have gigantic data, it might not be big enough to be able to answer your question if it's not the right data.